didn't leave much room to write on the right side. But let's start with an example in this case. So it will be something like this. We have another function that is looks like this: 2x minus 1 for all values of x except 3, and it's equal to 6 when x equals 3. So kind of you have a hole at x equals 3, but you plug it somewhere else, because if you do direct substitution, 2x minus 1 when x equals 3 is supposed to be 5. But instead of y equals 5, we have a hole over there at x equals 3, y equals 5, and we have a plug at x equals 3, y equals 6. Okay? Now, here's the thing. We need to find values of x such that the following happen. We want f of x, this function right there, to equal 5 plus or minus 0.1. Okay? So we don't want it to equal 5 exactly. We know that that cannot happen, because in order for f of x to equal 5, we need to replace x with 3. But when x equals 3, lo and behold, y equals 6. We have the whole. So we are looking at the limit, but we want to find, to come close to the limit, how close to? So the output y will be within 0.1 of the whole. Okay, let's illustrate this thing. So 2x minus 1 is a line. Intersected here at the -1, and of course when x equals 3, we're supposed to have y equals 5, but instead we don't. So we have a line that goes like this. Continue, okay? But at x equals 3, f of x equals 6, like so. So this is the function. Now, we know right here is y equals 5. And turn out, we also understand from the illustration that if we approach from the left and we approach from the right, this function has a limit that equal 5, right? And we want to have something different though. We want to approach 5 within 0.1. I'm going to exaggerate a little bit, and I'll say this is 5 plus 0.1, and this will be 5 minus 0.1. So what you're looking at a sleeve, sort of. We accept all values within that inside this sleeve, because we want to find 5 plus or minus 0.1. Actually, we want to find the corresponding x value, and the corresponding x values will be right here. Like so. So, the idea is this. For all the numbers, this one is 5 minus 0.1 or 4.9, and this one is 5 plus 0.1 or 5.1. Okay? This will be x equals 3, but we are interested to find x1 on the right side, on the left side, and x2 on the right side of x equals 3, which is the precise value of the whole. Okay, now, formally, or in a formal manner, we're going to write, we want f of x to equal 5 plus or minus 0.1. Another way to write it, this can be written, so the above can be written as the following. We can say that we want the absolute value of the difference between f of x and 5 to be within 0.1. In other words, what we are looking with this, with 5 plus or minus 0.1, means the tolerance of the output. We accept the output, the y value, to be within 0.1 of 5, whether above it or below it, or any values in between. In other words, any output value inside this horizontal sleeve. And we are in search of the input value inside this vertical sleeve that's bounded by x1 and x2 on either side of x equals 3. Okay? So here's, we're going to pick up two Greek letters that normally indicate small quantities. You know already the delta, right? Delta means a change, delta uppercase, the triangle. But if you have very small change, we call it, we use lowercase. So delta and epsilon are Greek letters used for or to indicate small quantities or increments. Okay, so delta and epsilon, and we're going to say that we want to find x that is plus or minus delta such that f of x equal 5 plus or minus epsilon. Okay? And in this case, epsilon equals 0.1. We want to find, I missed the word here, to find x plus or minus some delta. So x1, in this case, x1 we can write it as 3 minus delta, and x2 will be 3 plus delta. So what is delta? Well, delta will be the difference of x, of the value of x from 3. And it can go in either direction. Later on, we'll see that we can go in one direction, we'll have one delta, one difference, and we'll go to another direction, we'll have another difference. Okay? Now, notice that because we do 3 minus delta and 3 plus delta, we need to let delta to be positive. Okay. So we're going to say that if we let delta to be a positive quantity, then we can write x equals 3 plus or minus delta is x minus 3 equal plus or minus delta, or x minus 3 is less than delta or greater than negative delta. Again, if you look at it this way, or eventually we're going to say that x minus 3, the absolute value, is less than delta, like so. Similar to what we have here. Okay. So we are looking at two inequalities. This one here and the other one, f of x minus 5, the absolute value of f of x minus 5, instead of 0.1, which is the specific value, we have epsilon, which is the general value. Okay? So this is a preliminary part where we introduce the some notation, some Greek symbols, delta and epsilon. By the way, those are all lowercase. And instead of expressing, the way to express these two tolerances, the tolerance of the output, which is 5 plus or minus 0.1, now we're looking at 5 plus or minus epsilon, and we're looking at the difference. So where is epsilon? Well, epsilon will be the difference. I'm going to magnify this picture, and I'll show both delta and epsilon on the next page. So if we magnify this sketch, okay, let me just take this part right there. So this is the hole, right? And this is 5. Now, I'm exaggerating. So this will be, the difference will be epsilon. So this will be 5 minus epsilon. And on top, we'll have 5 plus epsilon. So epsilon is this measure. Okay? Epsilon is the deviation from the value of the limit. And again, correspondingly, this right here will be x equals 3. And the corresponding value to the left and to the right will be, well, this value will be x, 3 minus delta. This value here will be 3 plus delta, right? And the tolerance on either side is delta. So this is the magnification of the sleeve. Now, what we're saying is, if for each value of delta, we can find the limit within epsilon. Remember, the limit value is 5. Okay, and this is basically what leads to the precise definition of the limit. Let's see where I wrote it. It's quite wordy, so. Tell you what, before we go into the exact wording of the definition, let's solve the problem. Remember, we still have a problem to solve. Okay, so let's solve the problem. We want to find delta, right? We want to find values of x. And x will be 3 minus delta or 3 plus delta. So let's write x equal on this side. So we need to find delta. So basically what we are given, in this case, is epsilon equal 0.1, and what we need to find is delta that fits to our scenario. So we're going to start with what happened to the difference between f of x and 5, which is this difference. We know that it's less than 0.1, So since f of x is 2x minus 1, so we know that the quantity 2x minus 1 minus 5 is less than 0.1. And now we're going to try to simplify it until we get to x minus 3 is less than delta. So what happened is we started here with f of x minus 5 less than epsilon, and we're going to manipulate what we have here such that at the end of the day we're going to find x minus 3, the absolute value of x minus 3. And this will give us the delta. Okay. Let's see how this will work. So continue to solve this, and this will lead to the following step. In the following step, we have 2x minus 6, so the absolute value of 2x minus 6. The absolute value of 2x minus 6 equals to, if I'll pull out the 2, the absolute value of x minus 3. Wow, don't we need x minus 3 somewhere? And we know that it's less than 0.1. So what does it tell you about delta? I want x minus 3, so therefore the absolute value of x minus 3 is less than 0.1 divided by 2, or 0.05. So we choose delta to be 0.05. Okay. Remember what we want. We want to find delta such that the absolute value of f of x minus 5 is less than 0.1. So we want to find delta such that this happens if x minus 3, the absolute value of x minus 3 is less than delta. And well, let's take here that this is positive, because we said that delta will always be a positive quantity. So, having done this, having found out that the absolute value of x minus 3 is less than 0.05 and 0.05 is positive, that looks like 0.05 is a suitable delta value. So we're going to say that therefore we're going to choose delta equals 0.05. Okay, and that will be the answer to the question. And we can check, for instance, how we check it. Let me change colors here. So to check it, we're going to say the following. I think, Marianne, I think this is your pen. Somebody left his last time. Anybody recognize? I thought it was you. No? I think it matches the color of your hair, so I thought that was yours too. Oh well, let's check. I don't think I have good luck with green here, so I'll change to blue. Or keep it black. Okay, so let's find the first x1 on this side will be 3 minus delta. So if x equals 3 minus delta, it's really 3 minus 0.05. So we are looking at 2.95, right? And now what is f of 2.95? We want to be within 0.1 from 5. So f of 2.95 equals to 2 times 2.95 minus 1, if you recall. And this becomes 5.9 minus 1. So you can see that it's 4.9. So it checked out. Okay? So it's 5 minus 0.1. So it checked out. And So this is for x equal 3 minus L. Likewise, we can check for x equal 3 plus, delta. I said L. Do you know why I said L? You don't know. You need to know Hebrew to understand that. This symbol, the delta, is like the Hebrew letter lamed, which is the English L, exactly written like that. So you hear me saying L. So it will be 3 plus 0.05, 3.05, and then we substitute an f of 3.05, and you pretty much can complete it the rest of the way, minus 1. So we are looking at 6.1 minus 1. Which is 5.1, which is 5 plus 0.1. So you can see how this process works. Now, we can extend it and we can say, what happens if we change the tolerance? If you want to find delta such that f of x is 5 plus or minus 0.001, okay? It works the same way. So here's by extension. We can say the following. If we let epsilon to equal 0.001, then we want the absolute value of f of x minus 5 to be less than epsilon equals 0.001. Okay? So we're going to say that if x minus 3 is it's greater than 0, less than, remember here we had x minus 3 is less than 0.1 over 2, right, after this manipulation. What happened is we replace 0.1 with 0.001, so we'll take 0.01 divided by 2, and this will be 0.0005. Right? So this will be our new delta. Okay? And if we generalize it, just generalize, okay, for any epsilon, or if we have f of x minus 5 is less than epsilon, we're going to say that if x minus 3, the absolute value of x minus 3 is less than epsilon over 2 equal delta, like so. So we choose, in general, we choose delta equals epsilon divided by 2. And this is true for this particular function. For this particular function, for any given epsilon, we can choose delta to be epsilon divided by 2, and we are safe. We know that we are as close to the limit as epsilon.